Once again, verify the functions satisfy the ODE or not. And in this case, our ODE doesn't look very nice. It's y prime plus y equals y squared. So that won't be fun. And then the candidate function isn't very nice looking either. It's y of x equals 1 over c e to the x plus 1. So there's nothing to do but plug it in and see what happens. The first thing I'm going to do though is I'm going to compute y prime by itself. So y prime of x equals, and to make that a little easier, I'm going to change the way this is written. So this is the same as constant times e to the x plus 1 all to the negative 1 power. I'm going to make that parenthesis look a little more like a parenthesis. All right. So if I do it this way, I can use the chain rule. So if I take the derivative, the negative 1 will pop down. And I'll still have this piece here. So I have c e to the x plus 1. And that's now to the negative 2 power. But I also have to multiply by the derivative of the inside, right? So the derivative of c e to the x plus 1 is just going to be c e to the x plus 0. And now I get to simplify this. Let's go ahead and do that. So I have a negative 1 times this piece, so that's negative c e to the x. And then it is a fraction because this is to the negative 2 power, so that'll be c e to the x plus 1 squared. Right now we get to plug it all in. So we've got the y prime, which I've just computed. So I have a negative c e to the x over c e to the x, plus 1 squared. Then I have plus y, so the original function, plus 1 over c e to the x plus 1. And I want to know, does that equal the original function squared? So I have 1 over c e to the x plus 1, the whole thing squared. All right, well, this side doesn't look so good, but I need to get a common denominator, so let's go ahead and do that. So I still have my negative c e to the x over, I actually want it over, well, let's do one at a time. So I've got my c e to the x plus 1 squared. To get a common denominator over here, I'm going to multiply the top and bottom by c e to the x plus 1 to get the squared on the bottom. It's going to be plus, I have a c e to the x plus 1 on top, multiplying the same thing on the bottom, I get the bottom squared. So I have c e to the x plus 1 squared. And still wondering, does that equal the original function 1 over c e to the x plus 1, whole thing squared? Okay, well, I can simplify the left a little bit, so it's looking good. The negative c e to the x plus positive c e to the x cancel, and I have a plus 1 left over, so all I'm left with is 1 over c e to the x plus 1 squared. And yeah, that does fit, right? So if I squared both the top and the bottom, I get 1 squared is 1, I get the bottom squared. So yes, these actually are equal to each other. Let's see, c e to the x plus 1 squared. And so yes, for this differential equation, it's satisfied by this particular solution.